I'd like to finish talking about these energy problems, and the one thing we still need to know is how to calculate energy in a phase change. So quick review, we know that it takes 4.18 joules to raise 1 gram of water 1 degree Celsius. So we said it took 41.8 joules to raise 10 grams of water 1 degree Celsius, or 418 joules to raise 10 grams of water 10 degrees Celsius. So what about melting and what about boiling? Well, it turns out it takes a lot of energy to melt something. It takes 334 joules of energy to turn 1 gram of ice to 1 gram of water. That's with no temperature change, just to change it from ice to water. And that's called the heat of fusion. How much energy, how much heat it takes to melt it. I wonder if it takes more or less energy to boil something. Well, it turns out to turn it from liquid to gas, it takes 2,260 joules of energy to turn 1 gram of water to 1 gram of water vapor, all at 100 degrees Celsius. Just 1 gram.
Good morning, teacher. Just a quick reminder that it's 7.
Wow, it takes a whole lot more energy to boil something than it does to melt it. And that's called the heat of vaporization. Does that make sense? To vaporize something. That's how many joules it takes to vaporize 1 gram. So we look down at this problem. How much energy does it take to melt 25 grams of ice? Well, we look back up top. We say it took 334 joules to melt 1 gram of ice. So the heat of fusion is 334 joules for every gram. And we're going to do that with 25 grams. That's the mass. And what that's going to tell us is how much energy we're going to have to put into the phase account to melt something. So you probably have to get a calculator out for this one. Take 334 joules for every gram times 25 grams. We get 8,350 joules to melt 1 gram. This is the equation we're going to use for a phase change. If we don't melt, if we boil, we'll just change this heat of fusion